Alright, so for our next project here, we have a pretty exciting one here. This is a Hallicrafters S-40B that I picked up, and I really like Hallicrafters equipment. In the old days, I mean, you heard of Zenith and Philco and Emerson and Crosley and Atwater Kent and all these big names, and they were very popular in the broadcast radios, but in the shortwave, end of things, Hallicrafters was just as big of a name as the names that I just mentioned. And I really love restoring these and working on them. They usually turn out to be really good performers for what they are. And it's just a lot of fun listening to these old radios come crackling to life when you hook up an antenna. It's just something nostalgic about it, and really neat to see how sensitive they are. If we move over here, I'll show you a little bit in my ham station here. Here's a Hallicrafters S20 that's immaculate. It's completely restored. I've redone everything inside and out on it. It even came with the model SM40 signal strength meter, the S meter. Everything works perfectly. Beautiful how it kind of just lights up, and very sensitive. And I tell you, this thing picks up stations just as well as my ICOM here. Obviously it doesn't have the filters and things to perform like a modern radio, but it's just the nostalgia about it once again. And I've done several, here's one right there, of the S38s. I don't know if you could see that up there. I might get that out during these videos here. I'm going to do a series on this as I restore it. My S38 projects, I do a solid state BFO circuit upgrade to rather than that little gimmick that they use. This one uses the gimmick wire, but it also has an actual BFO in it. It's a little bit of an upgrade from the S38s, so it's not their top of the line, but it's still a very good radio in its own right. If you look inside, quite a few tubes in this. Just kind of pan around, and it's pretty obvious this radio has had some work done on it. I'm not sure what has been done. I haven't taken it apart. I've just taken it out of the box. Obviously this doesn't look stock. When I flipped it up and kind of looked through some of the vent holes, it looks like at least a partial recap has been done on it, and I don't know how that's been done. But we definitely are going to have our work cut out for us on this one. The good thing is, cosmetically, very, very decent shape. Not perfect. I mean, you can see rust, a little bit of rust, I really don't want to mess with the face of this thing, so I'm probably not going to repaint it. But I may clean it up a little bit and see if I can get it at least to look a little bit better. The dial's good. The dial glass is really good, or plastic, whatever you want to call it. So, again, I'm really looking forward to this project. Now, this radio is sitting on top of, as I promised before, I've begun the drawing and the design of the tube amplifier for the tube amp series that we're going to do. But I'm not going to show you any of that because that's for another video series. So, and I'm still waiting for some parts to come in for it. So anyhow, we're going to do this one. It's going to be several videos, I'm sure. And we'll start out by looking over this, looking over the schematics, talking about it, talking about some of the different similarities with the S38, the S20, and some of the higher end models. And we'll just have some fun with this. So sit back and relax, and we'll see where this video takes us. Okay, so if you've never seen one of these come apart before, I'll give you a little overview. On the bottom, there should be a whole bunch of screws that you can see here in the corners, none of which are in this. So you can see, you take out the screws here, 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 all the way around on the bottom, which are all we're missing when I got this thing. Then as we look along the side here, you have a couple of screws on either side, you can see. And finally, after you get all those done, lift this up and it just pulls right out. You can see down there how that comes out. And there you go. There it is. Just all one big chassis. Alright, let me get this repositioned and we'll be right back. Okay, so here's a view of the underside. And we can already see that they've started to recap it. There's one little electrolytic and one orange drop and two polyester, 3 polyesters that they replaced. But really this thing has not been redone other than those couple of things. And it looks like whoever did it did a decent job of replacing it. So of course all of this is going to go and get completely redone. All the resistors are going to get tested. Some of them may be perfect, some of them may be out. And then once that's all completely done, we'll go in and we'll do a full total alignment on this. Alright, and this one's a little bit involved. It's not a terrible one. It's a good one for people to learn on. Not as good as the S-38s. Those are a great machine to cut your teeth on if you're going to work on ham radios. But this one's a little more complicated, so it's a little more challenging, but it's still not a real bad one to do. So we're going to first of all kind of get acclimated with things. I'm going to print out some schematics, and we're going to try to locate some of the components in here and talk about them. And then we'll start proceeding with a little bit of testing and doing some of the work on it. Okay, so I dug out this model S-38B compared to the S-40B. If you look at the 40, is right over here. And we're going to flip this over and look at the bottom and do a little bit of comparison. You can see this is kind of a watered down version of the S-40. Okay, and if we take this apart, which I will do here, I'm going to hold on, let me get the cover off. I'll be right back. Okay, so as you can see, this one's been completely reworked on the inside. The cabinet itself isn't so great. It's got a lot of surface rust, and if I can get a good set of decals for this, I may order them sometime and fix all that. So here's what we've done in this one. Okay, this one's been restored electronically. And as you can see, we've replaced all of the electrolytics. We've replaced all of the paper caps. But the micas, you want to leave those alone. The reason is a lot of these are hand chosen for the oscillators and so forth in there. If you mess around too much with those, you can seriously throw off the radio and you really won't be able to get it properly aligned after that. So these rarely go bad. They do go bad once in a while, and then you have to do it, but for the most part they usually don't go bad. Made a little capacitor board to replace the capacitors, and this would be the oscillator I was talking about for the BFO. This is actually a BFO circuit, and you can see I'm still using a gimmick wire to introduce the BFO signal into the tube over here, but much more stable sine wave circuit. It is adjustable, so you can get a perfect adjustment on it. It's still not frequency adjustment on the outside, but it does a really good job, especially for CW. And you can buy these little kits online, or you can make your own. Really, they're pretty simple. It uses a little JFET and a few components you can see. Alright, and just a little crystal oscillator. So this is kind of what it looks like, but if you compare it, really it's not much different than this higher end model, other than this has some more controls on it that this one doesn't, and you can see same idea. I mean, this one has individual coils. You can see each individual coil. This one just has a coil form with all the coils stacked on it. Okay, and then these are your trimmer capacitors. Same thing over here. So it's going to be a very similar type of restore. Alright, this radio was rough when I got it. Had a lot of surface rust, which I cleaned a little bit, but I really didn't go crazy on it. I kind of wanted to keep it natural, keep it original. And you can see I only have 1 or 2 original resistors. All of the resistors had drifted really badly in this, and part of the reason was I think this thing got wet at some time or was in a damp environment. I was surprised that this chassis cleaned up as well as it did. You know, I had to tack solder some of these, actually all the sockets, so that they had good contact. And this radio is a really good performer now. It's actually a pretty hot radio. And you can see the tubes and the chassis cleaned up really well inside. The tuner capacitor, we got it like perfect. Okay, speakers, the original speaker that came with it. Kind of an odd little design. But this is it, okay? And we're going to go through and do some comparison. Now, this thing that I added here, okay, this BFO oscillator, actually they have one in this that's actually a vacuum tube. So it has a vacuum tube BFO oscillator, and technically you can adjust it on the front by adjusting the slug in this coil up here. Okay, so we'll get a little more into the theory on how that all works when we get the schematics out and everything, but I just kind of wanted to go over this with you and let you see some of the different things. The reason I really wanted to show you this radio is to see how simple it is inside. You can see there's not a lot. There's a lot of space inside this radio, so it's easy to work in. But the other thing, and the biggest difference, if you notice, this radio over here has an actual transformer in it, which provides isolation from the incoming AC line. This one does not. This is a hot chassis radio. That means the AC line comes straight in over here, goes right into the rectifier, and this chassis, if it were not wired properly, would be hot. Now, I put a 3-prong plug receptacle in here, as you can see. I wired the ground in, put the proper safety capacitor, and then turned around and made sure these isolators were still somewhat good. But as you can see, there's these little square block things right here that are supposed to isolate the inner chassis from the outer chassis, and those things are the only thing that was protecting you from getting shocked if you put the plug in backwards. They were non-polarized plugs, and theoretically you could have AC voltage on the chassis of this. So you touch this and you touch something that's grounded and you get a severe shock. Now, by rewiring the switch, and there is a little diagram, we can go over how to do it. You can rewire these so that the ground prong goes to ground, the neutral ties to ground, okay, and you can only plug it in one way, and that makes it a lot safer, that even if this inner outer chassis insulator were to break down, you'd still be safe. You wouldn't have to worry about getting shocked. Alright, so again, a fun project, and you can find these S38s on eBay. They're pretty common. They made a whole ton of these things back when they were in production. So they're very easy to come by, and they're very easy to restore. And there's a lot of good websites on there that talks about, you know, restoring these, and some mods that you can do. There's many different BFO mods. I actually had some homemade ones that I built that work pretty well. But I really like that little kit. It was like $15 online, and you can buy them, and it comes in a little kit you make yourself, and they work really, really well. So that's a little bit on that. And now let's get to some schematics here. I'll finish putting this together off camera and get it out of the way, and we'll get back to our S-40. Alright, so first things first, I've printed out some schematics, and there are a few different revisions of this. You know, there's the original S-40 has had a couple of rebuilds, and of course this is the S-40B model, and to my understanding the B model does not have an external plug, whereas the original S-40 does. You can see here there's nothing in here. I'll get some other schematics later, but down here there would be a printout, you know, of a connector plug where you could plug in one of those optional S meters and so forth, like we have in our S20R. This one, they did away with that with the S-40B model. So you can see right here, one of the things we're going to look for real quick is this half of a 12SG7 V5. This is for your BFO oscillator. And you can see they're showing C38 as a gimmick capacitor, and it goes up there, and it is going to loosely couple to V4. So somewhere in here we should see a wire coming in and just kind of laying across one of the tubes here. Now they're saying V4, and if we look at our tube layout, let's see here upside, should have a printout of that. Let's see if V4 is even listed. Boy, this is a bad printout. I'm gonna have to get a better. I'm gonna go to Staples and get some larger printouts. There we go. So here we go, is what we have. And unfortunately they are not telling you V what, you know, what they are, but the 6SK7, which is V4, there's actually a couple of them. There's two of them right here on either side of this, so I'm looking back in here somewhere. Neither place, okay, and neither one of these tubes here am I seeing the gimmick capacitor. Now I see this little, yeah, I don't see it. So it looks like somebody was in here messing around and they didn't know what they were doing, and they essentially removed the gimmick capacitor, because I do not see it in here. So I'm going to have to do a little more research. Like I said, I just opened this up, but we're going to have to look. Okay, after a little further research, let me zoom in here and see if I can get this close enough so you can see. If we look right here, I had this capacitor was doing this. If you look underneath here, right there is your gimmick wire. So it comes across there and it ties in capacitively to the second IF, which is V4, and it is V4 pin 4, and you can see that gimmick wire ties right up into there, and it is coming from clear, let's see here, right up over here, right there, from V5, which is right here, according to the schematics. Let's see, make sure I'm right. Yep, V5, which is your BFO oscillator circuit. And you can see here's your coil for your VFO oscillator, and comes off of this pin, goes through this little shielded wire right here. You see, it follows all the way down, follow all the way down, all the way around, and hooks onto this right here. So there you go. On the S-38, they actually couple it by running it right past the pin. Okay, it's a new day, and the weekend is almost here, and in a couple more hours, if I don't get called out on any more service calls, I will begin my weekend. So I went out and I printed some schematics and some documentation on this S-40. Up until this point, we've been just kind of poking around in here, looking at some of the components, trying to identify them, trying to see some of the things that were done already, and locate where some of the things like the gimmick wire are. And one thing about the S-40 is this was in production for a while, and there are multiple versions of it that are different from one another. There is a pretty substantial difference from the S-40 and the S-40B. Now this one is a S-40B model, and one of the things is it does not have a speaker plug, uses a permanent magnet speaker, whereas I think some of the older ones actually have a field coil speaker, which I could be wrong, but I think they do. I know the S-20 has a field coil. But more importantly, if you look at some of these, some of the tube layouts, they are definitely different. This is an S-40, and if you look at the tube complement here, this is underneath of chassis, says bottom view of chassis. And you look how V6, V8, V5, V7 are all in a row. Alright, then you have 4 and 9, 3 and 1, and 2. If we look underneath here, we don't have anything near that. Okay, so we have 2 tubes here, 2 tubes here, 3 tubes here, and 1 tube here. So we got to watch that. I'll be right back. Okay. When you have children and a wife and everything, you get interrupted sometimes. I sound like one of those commercials. It's what you do. All right. Anyways. So, again, having printouts of the different ones, some of them show some things that other ones don't, but you kind of have to be careful. Here's the S-40 again, and even with the S-40, if you notice, there's a first and a second revision. And if you look at the first revision here, they're showing the output here. If you look at down in the corner, they're showing you a rework of this is the first edition, this one's the second edition, and obviously they've made some slight changes. Again, these ones actually have the plugs on them, and you can see part of it is going to the power supply. You have to put a shorting jumper in there. So, and I don't know, it looks like that allows it to be run on battery. Just looking at this right now, AC operation, you see that? So the older ones must have had the ability to run off of battery, and I do know on the S-20 in this plug there was also provision for an S meter, an external S meter, which this may or may not have. I've not read a lot on these yet, so I'm still learning as I go along. But obviously you have to make sure you get the right schematic and to match the correct unit that you are servicing. So this one most closely represents what's going on, and this is of course the S-40B. And I do have in smaller print an S-40B service manual, and unfortunately it's not real legible. As you can see, it was a copy of a copy of a copy of a copy, but we can at least use this and use the tube layout, which they did not mark the tubes here for some reason, but we can use this to map out the under chassis. And if you flip it around this way, this is the orientation that we're looking at, and we will be able to figure this out. So what I'm going to do right now is I'm going to look at these, the location of the tubes, match it up to here, and then mark all that. So we actually have a map. So when we want to look at V5, pin so-and-so, we know where that is on the map. So I'm going to do that, and I will be back. Okay, now we have our tubes all marked, so we can identify kind of where things are. Alright, I always like to go through all this and make sure I know where everything is and understand how they've located it before I touch anything. And I go through and do all this and identify things so that if somebody else has worked on this before and has really majorly changed something that might cause a problem when you power it up, I try to find that out ahead of time. I don't always do it, but it helps. So we go through and do all this, and everything pretty much looks to be in order for the most part. So the next thing we're going to do is we're going to bring this up slowly on a variac. So right up here is what I use. I have a adjustable isolated variac. And just so you understand, this is not just a variac. There's a variac, and in the back of it is an isolation transformer. So even though there's 3 prongs on this, they do not go to the ground prong on the plug. They actually are isolated, and therefore, if my test equipment is grounded and I get something switched around, I have power isolation. So it really reduces your chances of electric shock. Again, you're working on something with live mains power. You're also going through this transformer, and you're boosting things up to 200, 300, 400 volts in some instances. This is very dangerous, and you can get a very severe, painful, and sometimes deadly shock. So again, do this at your own risk, and don't do it at all if you're not trained, if you don't feel comfortable around this sort of thing. Having good common sense will take you a long way on this, but you still have to have knowledge of how you can get injured and how you can avoid getting injured. So anyways, we're going to flip this around, put it on the variac, bring it up slowly. If we hear a little bit of sound, then we're going to, I may even turn it on its side and connect the voltmeter so we can kind of monitor the main power coming at the B+. And see if this thing makes noise. So let's do that and we'll be back. Okay, here we are. So, looking on the schematic, I'm connected to pin 2 of the rectifier tube, which basically just goes straight up into filtration. That's your B+, okay, the beginning of your B+ line. And with respect to ground, okay, a grounded chassis. So, and I have this meter for the AC, and we are using it to monitor our incoming line, so we can look at how much we have. And I also have a meter up on the variac, but figured this would be easier for you guys to be able to see. And let's start bringing this up slowly and see what we get. Alright, and first of all, let me get some volume turned up, and let me turn on the power. Okay, here we go. Let's start out with about 25 volts. Okay, do about 25 volts. And so far, I am looking at the current on my built-in meter to the variac, and I have almost no current at all yet. Okay, so we're going to keep coming up. And you can see if I'm already starting to get a little bit of voltage, even with 26 volts on it. So it tells me that the at least the transformer has continuity, and the rectifier tube is pretty snappy here. So let's come back. Let's come up to about 50 volts. All right. So let's go to 50. And we're already up to 188 volts. Usually around 60 to 70 volts, you'll start to hear the radio come to life. Alright, and looking in here, a lot of the tubes are metal tubes, so obviously we can't really see if they're lighting up. Okay, and let's make sure we're on receive. Okay. 75 in there. And let's look at this and see if there's any voltage ratings. There is a voltage chart, and it's right here. Now obviously, let's look on our rectifier tube, and I am on, it's saying about 350 when we hit maximum voltage. We should have somewhere around 350 volts. Okay, so let's keep going. Put 100 on there. That should be enough to get some sound. And I'm not even hearing crackling from the speaker. Yeah, there's a little bit. Hear that? Okay. However, I'm not really getting much of any kind of volume. Okay. And it was my understanding this thing worked. We don't know how well, but okay. Nothing. So let's bring it up a little more. And I'm going to go 117 volts roughly. The reason I do that is a lot of these older systems, well, it says right on the schematic, that's kind of strange, but this one says 105 to 125. So this one's good for modern line voltage. You have to watch that. Some of these older receivers were designed for 117 volts, which was routinely what you would get back in the 30s and 40s. Now, you know, our modern power is more 125, 126 volts, so I usually don't like to overdrive these at first. So there's plenty of power here. I'm not really getting... I have an antenna connected. Okay, here we go. Nothing. Okay. So with that in mind, let us see if we're getting anything. Pin 4 of V5. V5, 6C7, V5, which is up here. Pin 4. 1, 2, 3, 4. And as you can see, where I'm touching here, and I'm not using my finger, I'm just using a screwdriver, I'm touching this input grid right here to the driver tube. That's your first audio. That's your first audio. See, it comes right after the what do they call it, discriminator diode or whatever they call it. I'm having a senior moment. Anyway, right here, if we touch that. Pin 4. So that tells us that the amplifier is working, okay? But it also tells us that the radio is deaf. We're not getting any kind of signal. Now, strangely enough, when I got this thing, you can see I can touch the antenna, and I can get a little bit of static. And I can touch the kind of with the insulation, I can touch the capacitor on the top, you know, the little terminals on the top, and get a little bit of sound, you know, some noise through, but no signal whatsoever. So we know we have good voltage, okay? Actually, we have really good voltage. This thing's calling for, once again, it's calling for about V8, 350 volts, and I'm already up to 380. So let's do something else here. Let's go to AC volts. And if you look at AC, there's nothing there. So, I mean, as far as the capacitor is concerned, let me touch it. It's ice cold. So the capacitor is probably at least functional right now. Alright. Okay. And this tube here is getting really, really hot. This one here. And that is a, can't see it from the light. We'll have to look that one up. And if we go here, turn this back to DC. And if we go here, that would be this tube, V3. V3 would be a 6SK7, and there's no way that the 6SK7 should be that hot. V4, which is right here, that's warm too. So they're both they're pretty hot. So obviously something is not right with this thing. So we're going to turn it down. Okay. And my first suspect is going to be these paper capacitors. I'll wait till this bleeds off. But I believe that one of these paper capacitors is shorting, and that's what's making these 6SK7s. I mean, they're hot. They're really, really hot, and they usually don't get that warm that fast. Okay, I'll be back. Alright, sorry about that. Had a phone call come in. So, where we left off is most likely we have a shorted bypass capacitor or something in here. Voltage is pretty high over here. It's way above the 350 that they're calling for. So obviously we're just going to kind of have to go through all this and find out where we're losing it. Now, usually what you do is you can kind of go into the grids of these, yeah, and you can just touch them with a screwdriver. You know, hold the handle and kind of just touch and go through it, and it should make some sound. If that tube is working, you should get some hum and some noise. If you're not getting that, that's pretty much where it's ending. Now the other tool we could use if we wanted to is right over here, and maybe we will use that. This might be an interesting thing. I haven't played with this in years. But basically what this is a signal tracer. And all it does is, it's just basically an amplifier and basically a little diode, a little detector diode, and an isolation capacitor, and it just amplifies the sound through the stages so we can follow it through. So maybe we'll do that. Let's try that out. Typically I wouldn't go that way, but that might be something fun. So let's do that. Alright, so let's hook it up and we'll be right back. Okay, so here's the plan. We have the radio turned on, and we have signal generator with my as you can tell, homemade probe. There you go. And basically all we're going to do is kind of step through this and see if we get any kind of sound. Alright, so first of all, let's get on to the output of V2, alright, which is going to be pin 3, I believe that says, of T11. Alright, so let's go over here and see if we can find this little transformer here. Let's go V2. Let's see here. And come out of pin 3 of V2. So V2 is this one in the upper corner. And if we want pin 3, we can even catch it on the other side of that 390 ohm resistor. And again, this has an isolation capacitor, so the high voltage will not affect it. Okay? So 1, 2, there's 3. And you can hear there's no sound. Now there's sound coming through the speaker of the radio. And if I turn this up a little bit, nothing. Okay? So let's go back to where C62 is, which would be V1. And we want to see V1, which is right up here. V1. And we want to go off of pin, boy, that's so hard to read. I can't tell what that says. That's pin 3 or what that's saying. Can't tell. But there should be a resistor R4 coming off of V1 off of the plate. And looks like it says what, 39 ohm or 32 ohm. So that would be like an orange red, and I don't see that. I don't see anything like that here. Oh, what's this up here? That's pin 8. And it comes off of, it goes right on to V2. V1 over to V2. So it would be the one that comes across here. There it is. Let's see what we get. Nothing there. Let's put an antenna on. See if we get some hiss. Okay. Nothing there. Nothing there. Nothing there. So by the looks of it, we're not getting our oscillator's not working at all. Okay. This first tube, V1, is your RF amplifier. Okay. So let's talk about that for a second. I'm going to shut this back down because that tube keeps getting hot. Alright, this is a little bit of review for some of you. You who are kind of new to this whole thing, let's talk a little bit about the design of a radio. What I was checking was the way these radios are set up is that S-38 that we looked at before, okay, does not have one of these tubes, okay? So this is called an RF amplifier. So what it does is, you notice, here's your antenna coming in. Here's all of your coils, okay, for tuning. When you tune in a station, you're making this circuit resonant with the channel or the station that you're trying to pick up from the antenna. You are then, with this radio, it goes through a little amplifier and it gets boosted. Now, that's a good thing in that it boosts that radio signal, okay, early on in the stage, but also it will boost the noise along with it, okay? So it's kind of a trade-off. However, you do have a stronger signal coming out of here, all right? At that point in time, we have another set of coils, and they are tuned 455 kilohertz off of these coils, okay? And our original signal, our radio station, gets mixed in with this second oscillator, and they're 455 kilohertz apart. That's called, when you mix these two signals, it's called heterodyning. And when you heterodyne the two signals, the output of this is going to be, you're going to have several things get through this filter network. Okay, you're going to have the original two frequencies. So you'll have the tuned frequency of your station, tuned frequency of the oscillator, then you'll have the sum of these two different frequencies and the difference of these two different frequencies. And what this circuit here, this is going to do is it's going to filter out everything except one, either the sum or the difference frequency, which will be 455 kilohertz. Okay, so that's called a super heterodyne radio tuner. And what that's going to do is every channel from that point on is always going to be 455 kilohertz. So the only part of the radio that has to tune the stations is the front end. And this all the rest of this radio is tuned to pick up one channel, 455 kilohertz. And so when we do that, this is called your intermediate frequency. That's what that 455 kilohertz signal is called, or your IF stage. Okay, the IF then gets amplified more times. So you notice this one, you've got 3 different tubes. Okay, so we're amplifying it a couple more times and boosting it. Then once it comes out of there, we detect it with a detector diode, and that's what this does. So all this does is it takes all the RF component off, and the amplitude modulation, which is your audio, your sound, okay, which is riding on that 455 kilohertz carrier, as we call it, because it's carrying the sound. We get rid of the carrier here, and we only let the audio here, and then that comes into your preamp and goes into your amplifier out to your speaker. That's how this works. So to troubleshoot one of these is pretty simple. Okay, you can either start at the beginning and work your way out, or you can start at the back and at the front, at the end here, and work your way back. Okay, so obviously when I touched my little screwdriver on this input grid here to this preamp, I got static. So I know my amplifier is working. I get sound through here, and I get sound through here, sound through the transformer, sound through the speaker. I went back into this area, and I'm getting noise coming through all this, but I'm never getting any kind of static like I'm picking up a station. The reason it's doing that is I'm not getting a super heterodyning, and I'm not getting my 455 kilohertz because of that. So this is blocking everything back here, if everything is back here at all. We don't know. This tube could be bad. But the other more common thing that could be happening is this section, this oscillator section, is not oscillating. If you don't have what's called the local oscillator, this is the thing that's tuned 455 kilohertz off of your radio station tuning, you're never going to get that heterodyning. You're never going to get that difference of 455 kilohertz, and you're never going to get anything through the rest of this. So you get a deaf radio, as they call it. Now, there's multiple reasons that could happen. Any one of these paper capacitors could be leaking. And when I say leaking, I'm talking leaking electronically. And if they leak electronically, that means it's just like taking a resistor or even a dead short wire and just shorting the two leads of that capacitor together. So you look, some of these capacitors are pretty substantial, what they do. Some of them go straight to ground. Now, capacitors block DC. So you have DC up here. But if you short this, you are taking that DC and you're shorting it to ground. So when you hear about people recapping a radio or recapping a receiver, the reason they do that is these start to fail with age. Okay, the acid in the paper that they use in there will break down, and they will begin to no longer act as a capacitor. They act more as either a resistor or even as a short as they get older, and that's called leakage. When capacitors leak, They block signals, and wherever that leaky capacitor is blocking, from that stage on, you're going to get nothing. And that's what we're kind of looking at right now. And now, let's say something out here was not working right. When I came back in here, I should have heard my radio station, okay, through my signal tracer. Since I'm not hearing any of that, I'm assuming that somewhere up here we've got a problem. Now, there could be more problems also if there's multiple capacitors leaking, but we know we at least got one issue where we're probably not getting our local oscillator. And it doesn't seem to care what band I'm on, so I kind of can rule out these, because each time I turn one of these knobs, you know, to change the band, okay, AM and, you know, the higher bands and lower bands, I'm bringing in another coil, and of course, not all of them, yet probability of all of them being bad is pretty low. So we know either got a bad tube or most likely a leaky capacitor. So I was really hoping to at least get some sort of radio signal up at the front end of this thing, but we're not. So where do we go from here? Well, first thing you always do is rule out the obvious. We have tube testers, so we're going to take the tube tester out and we're going to test all of our tubes. We're going to make sure that they have been plugged into the correct sockets. I've seen radios I've pulled in that somebody has swapped tubes around and they're not correct. I've seen a lot of things like that. So we're going to rule out tubes first. We already know we have voltage, okay, for the most part. We know we have filaments, but we don't know about our tubes. We don't know about our capacitors. So tubes first, because they're an easy check, then the capacitors. Now this whole thing is going to get recapped anyways. I'm going to do a full restoration, but I always like to see the radio work as best as it can before I introduce more problems. I mean, you know, maybe there was a problem here to begin with and I threw a part in here and I changed something and I added another problem. I'll never know that, okay? Or I replaced a problem with another problem. You know, by when I put that component in, I put it in the way of the one I found. I just put in another problem, right? I took it out, put it right back in. So it's nice to see these work before you start tearing into them. And again, this thing has had some modern service. These are modern capacitors. So we're going to go through all this. And so let's check the tubes and let's go one step at a time. I'll be back. Okay, let's get you zoomed in here a little. So we have our tube tester set up. Sorry about the odd angle here, a bit tight. And I'm just using my little emissions tester. This thing works great. I do have a mutual conductance, fancy, blah, 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 but I'm not matching audio grade tubes. I'm just trying to see if this thing has emissions or not. Check the tube. So let's turn it on. We are checking our rectifier tube. And if you look right away, diode's okay. Now, why did that pop up so fast and not really warm up? Reason being is some of these rectifier tubes are what we call direct heated tubes. And what we mean by direct heated is that filament is the cathode. It is the cathode element. Okay? It's connected right to the filament. On an indirectly heated tube, like a audio output tube, you know, like a 6L6, 6V6, whatever, they're indirected, meaning they have the filament running up through a metal sleeve, and that metal sleeve is heated by the filament, and the sleeve is your cathode. What that does is, number one, it kind of can reduce hum because you don't have the AC pulsing through the filament. And number two, it gives a more even distribution of the heat to make a more, you know, even current flow. On a rectifier, it's not so important. Okay. So if you look right here, diode's okay. It's low, but I've got something now. There's two tubes inside this one envelope. Okay, because it's a full wave bridge rectifier. So you see two filaments. You see two little elements here. One of them is one diode, the other is the other diode. So right now we're on selector 4, which is going to be your first tube, okay, or your first rectifier. Then we move it over to 6 to check our other rectifier, and you can see it's exactly the same. So the tube is working, and I would have expected it to work because, once again, we were not getting hum, and we were getting high voltage. So we've just proven this tube is good. All right. So let's come back and we'll put one of the signal tubes in. I'll go over that with you, and then I'll check all the other ones off camera. Okay. I now have the 6SK7 in there, and I've turned it on. And as the tube, now this one is indirectly heated, and you notice it took it a while to heat up that little filament sleeve. I'll be right back. Okay, between children and phone calls today, lots of interruptions. Anyway, this is one of the 6SK7s, and it is the one right, it's V4. Okay, so on the schematic, V4 is our second IF. Okay, so I think it would be the second IF is what I'd put. Yep, second IF. There it is, V4. So second IF is reading good with emissions. And then to read shorts on this, okay, and really you should do it the other way around. You should read shorts first and then read the emissions, because if there is a short, it could short out your meter, okay? Technically, I've never had that happen, but I've heard that rumor that could be possible. So 6SK7, we move our shorts position, and it says for 6SK7 we ignore indicator when we're on number 7 if it lights up. Okay, so we start all the way around, and you just go right around here. There's the false short, and you can see there's no shorts. Okay, so we go back to 4 and go back to regular, and we have a good tube. Okay, now again, we don't know the mutual conductance, and we don't know if it's noisy. We don't care right now. We just know that this tube would work in circuit. Okay, at least make some kind of signal. So what I'm going to do is I'm going to go through all of these tubes, and I'm going to test them the same way, and we're going to rule out anything. My gut feeling is that we do not have a bad tube, although it can happen. Tubes are pretty reliable. They last a long time, and even when they start to go bad, they still function. They just don't function optimally. So my guess is we're going to find all good tubes. So when I come back, I'll let you know what I find. Okay, here's where we are. We have this 6SC7, and it is a dual triode tube. And what its purpose is half of it, the first triode, let's get the schematic, I'll show you. The first half is this one up here that we were checking, which is your preamp or your driver tube for your output 6K6. See? The other half is for your BFO oscillator. Alright? And as you can see, both sides are bad. Okay, this one started out down in the red. It's climbed a little bit after being on for a while, but by and large, this is a bad tube. Now, it still can make sound. It will still work somewhat, but it really needs to be replaced. Okay, this will not cause, I don't believe, the problem that we're having right now. First of all, we're not even using half of it because we didn't have the BFO turned on. Okay, that's only when you're in CW mode. So half of it's not being used. The other half, if you noticed when I touched it, I got sound. So I'm going to put this tube back in for right now, but we do have to remember that this one's going to need replaced for it to work optimally. Alright, so I just wanted to show you that. I have two more tubes to test, and we'll see. So far everything else is checked out perfect. Okay, and wouldn't you know, even our 6K6 is reading weak. Again, it will work, but not optimally. And that's probably why the radio's not that loud, even when we are putting sound into it. So we're going to need to get those two tubes. Okay, eventually we will need a 6SC7 and a 6K6. And but for right now, for troubleshooting purposes, it'll be fine. Okay, it just means that it's not going to work as well as it could. Okay. All right. Okay, I finished testing the tubes, and they all turned out good. Okay, other than those two that were weak, the other ones all tested out good. So I don't think we have a tube problem, and I didn't think we did in the beginning, like I said. Now, another thing, our next thing is the capacitors, but I do want to bring up one more thing, and that is the these transformers here. Okay, these little IF transformers, they're called. Okay, and those, you always see those in these radios. Let me swing this down if I can without breaking everything. If you look, that would be these little things here. Okay, you see them? Those are your IF cans, or your IF transformers. Okay, and for those of you who aren't into radio yet and just getting into it, the purpose of those, like I said, are to filter out everything but that 455 kilohertz carrier with its audio riding on it. And if you look inside of these, there's a capacitor. There's two capacitors. One is, and basically these are tank circuits. You have a capacitor and a coil, and anytime you have those two things, they'll oscillate. Okay, and that's what these are for. They're a tuned resonant circuit. And these little capacitors, if you notice, those were little square cans. They were about 3/4 of an inch square. And those are the newer style cans. Okay, the older ones were a lot bigger, and they had those big mica capacitors like this. These tunable ceramic, they were mounted right inside there in those cans, and you adjusted those. These newer ones are a little different. They have a fixed value capacitor, and then if you notice the little line going through the core, that means the slug or the ferrite rod inside the core of that coil is adjustable. So these ones you adjust by adjusting the inductance, whereas the older ones you adjusted by adjusting the capacitance. These are much cheaper. They were very inexpensive to mass produce, but they also had a terrible flaw called silver migration. These little capacitors are silver mica, and all they are is a little flat pad that sits at the bottom of that can underneath that coil. Alright, and there's some little metal tabs that touch them, so you have basically a mica insulator, silver mica, with a little metal contact on either side, and that makes up your sandwich for your capacitor. What happens is, over time, that the silver will kind of come off of the little contacts and migrate onto that mica, and actually cause it to have like a tarnish. That tarnish is non-conductive. It changes the capacitance, and sometimes even causes it to fail or to leak, and these don't work anymore. So the reason I'm explaining all of that is sometimes you go through the whole mess of recapping a radio thinking that it's a wax capacitor that's bad, and it still doesn't work. And if you see these little cans, you have to be aware that these are very suspect at that point. So I'm going to recap this, and I may do a little more poking around, and hopefully we don't have to try to repair these. We can, and there's a way to do it, but it's a lot of work, and it's real delicate and touchy, but if we have to do it, we have to do it. So with that being said, I'm going to call this part 1, and we're going to stop right here for this video, and I'm going to post it for you all, and when we pick up on part 2, we're going to start with the rest of our troubleshooting. Hopefully by the end of part 2 we'll have the radio at least in a functional state, or at least knowing what we need to make it functional, and then we can start the actual restoration, okay, and move on from there. So again, this is part 1. Hope you're enjoying it. The vacuum tube amplifier project, I'm working on that. I'm still waiting on the output transformers. I found out they take about 6 weeks to ship. So, and there's nothing special about them. I just ordered them, got a good price on them, and that's an American company and so forth, and thought I'd try them out, but they make a lot of their transformers to order. So that project's going to come after we're done with this project. So that's part 1. I hope you stick with me on this, and if you liked it, give me a thumbs up, and we'll keep them coming. Have a great day. Thanks.